Hello, everyone. Thank you for being here today. I really appreciate it. My name is James Malone. I'm a product manager in our data analytics group at Google Cloud Platform. I'm happy to be joined today by Simon from Vodafone, who you'll be hearing from after me. And thank you for coming. I really appreciate it. Before I begin, I really do want to implore you to please provide feedback, not only on this session, but other sessions as well. We really do take this feedback to heart to try and improve both the sessions and Next every year. The feedback opens 20 minutes after the session begins, which is when Simon will be talking. So whatever I say, please don't take it out on him. And remember to give us 5 stars, because we will try and give you an awesome presentation. So I want to start off talking about data. It's probably no surprise that by 2025, it's estimated that 175 zettabytes of data will be generated. Most of this data will probably be stored in the cloud, just based on capacity and availability and ability to query and make sense of this data. And this is a really big number, and it's great, and we can talk about what it actually means. But let's talk about how it manifests today and the data quality and the data size that we know today. And I'm going to use the Spark and Hadoop ecosystem as a basis for explaining some of the pain points for just all of this massive data that we are already generating today. If you take a look at the Spark and Hadoop ecosystem, there's a whole lot of pains. And we're not at the 175 or 300 zettabytes of data yet today, but there's still real pain that people are feeling today with just the data sets that we know. First, it's really hard for people to scale to make sense of their data. You may need a lot of capacity in terms of storage or processing ability, but often there's a lag in requesting that capacity or even making use of that capacity if you have it. Utilization is also really hard. Often you don't utilize infrastructure, whether it's storage infrastructure, processing infrastructure, 100% of the time. That leads to cost pain. People are either over-provisioning or under-provisioning their capacity. Neither are great. If you're over-provisioning capacity, you're paying for stuff you're not using. If you're under-provisioning capacity, you're letting things drop to the floor. Neither one really is that great of an option. Our goal as a platform is to try to solve these problems, acknowledging that we're generating more data, and that's just going to be a reality, whether we like it or not. We need to provide tools that are integrated, that help you solve these problems. First, we really don't want you to pay for more than what you actually need to use. Using Dataproc as an example, which is our managed Spark and Hadoop service, we're 57% less expensive than on-premise infrastructure. Again, we actually do optimize for cost. So I'll give you another example. With Cloud Dataproc, we optimize the cloud storage connector almost weekly. 1% here, 2% here another week. The overall goal is to try and actually save you money, not try and decrease performance so you end up spending more. We want things to really be fast. Things shouldn't take hours, weeks, months to get going. You should be able to get going in minutes or seconds. Again, time is really money when you're trying to make sense of data. Third, we want things to be really fast in terms of infrastructure. So using Dataproc, which is our Spark and Hadoop service as an example, instead of getting a cluster in minutes or hours, we optimize for speed. In average, it's about 90 seconds, and that's going to go down over time. We want to bring new capabilities to make sense of this data as well. So this is where things like TPUs really come into play. A couple of years ago, when we first announced TPUs, it was really unclear, and I sit in the open source world, and my product portfolio is managed open source. It was really unclear of what will TPUs mean for something like Spark. Today, we actually see TPUs commonly used with Spark analysis to do things like feature extraction, or to try to create models to predict what is going to happen in a data set in a given point in time. And that really important point there is it's about trying to offer new capabilities, even sometimes before we know exactly how they're going to be used. Finally, it's really important to take advantage of the Google infrastructure to make sure that we're providing a comprehensive portfolio for security and governance. And this is actually an interesting area where I love to nerd out. So if we think about something like our network infrastructure or Titan, these are platform things that you may not be aware of, but that keep your data safe. And it's really important that we build products that are founded on these fundamental building blocks. In this slide, I really actually wanted to call it a platform powered by Google Cloud Platform, but I thought that just sounded kind of funny, so ended up going with Data Lake. The important point here is it's not up to us to just offer you a grab bag of products. And I think that's often what it can seem like when you look at documentation, because you see all these icons, you see all of these products, and it sort of doesn't seem like there's a strategy behind it. But I'm using this example of Data Lake to try and show you that there's a lot of thought that goes into how all of these things fit together. So if you take a Data Lake as an example, cloud storage makes for a fabulous, just cold sink for data in a data lake for many reasons. It has multiple tiers, so you can have nearline, cold line, standard. You also have regional, multi-regional buckets. You can set policies at the bucket level or the object level. So it's a pretty good just store of data. We have a whole set of ingestion tools that are specifically designed to work with cloud storage. We want you to be able to easily hydrate and put data inside of a cloud storage bucket. So things like PubSub, transfer appliance if you're transferring physical data, interconnect for networking. We want you to be able to seamlessly be able to put things in that bucket. Likewise, we want you to be able to seamlessly make sense of what is inside of that bucket, and that's where our processing and analytic tools come into play. Things like BigQuery, Dataflow, Dataproc. These things really are designed to work and interoperate together so you have a cohesive set of tools. It's not just giving you BigQuery and giving you cloud storage. We really do put in a lot of thought about how all of the pieces fit together. There's some peripheral tools that we are developing or have developed to try and help you make sense and use all of the processing and ingestion tools more effectively. This is where things like data catalog come into play. And we want you to be able to be sure that your data is safe. So this is where things like Cloud IAM, VPC, SC come into play. So you have a cohesive set of tools. Now I can tell you have a cohesive set of tools, but it makes a lot of sense for you to actually hear somebody who's put them together and to solve a series of problems. And with that, I would like to welcome Simon to the stage.
Thank you very much.
Thanks.
Thank you very much. My name's Simon Harris. I'm head of big data and cloud analytics. I'm going to walk you through our analytics journey to Google Cloud, and then I'll sprinkle a little bit of our overall Vodafone strategy of where we're going in terms of cloud. My goal is to tell you why, how, and then what we're going to do next. So everyone has a big statistics page. I'm not sure who the guys on the moped is. I think the important thing to understand is we are one of the world's largest telecoms companies, but we are so much more. We provide TV. I'm not sure you get it in the UK. We provide HD voice over LTE. Yeah? We have over 94 million SIMs in our IoT business, and that's being used by BMW and Porsche. We are in 19 markets, and we are providing 27 million customers broadband. One thing that's not up here, and one of my favorites, is M-Pesa, which allows customers to send payments over their mobile phone. So just so you understand, Vodafone is more than just mobile. So everyone has their billion slide. Yeah, we've got to have a billion in there. We're not at the trillion mark. I think the two key points here, and obviously corporate comms wanted me to talk about all of them, but I think you want to hear about the technology. The two things to understand here is, over the past financial year, we have transmitted over our network over 2,730 petabytes of data. And just so you know, it's not going to get smaller, because with 5G around the corner, it's going to get even bigger and bigger and bigger. The other important thing is, I work for Vodafone Group, which is the central body, and there are over 24 different countries with Vodafone Italy, Vodafone Spain, Vodafone UK. So we want to, and the important message here is, we want to change our perception from being a utility to a tech company. So Nick Reed came out and said that he wants to move the mindset of Vodafone and how it's appreciated. What he wants to do is actually bring capabilities in-house, and he wants to use technology as a way of differentiating. So we want to make sure that you, have a fantastic experience. And we want to know that you love what we provide. And we see Google as an enabler to do that. So, where did it start? In the beginning. Well, it's important you get some context. So I'm going to talk about analytics specifically. So it's important to understand that Vodafone already has a very much mature analytics capability. We use our analytics to retain our customers, to optimize the packages that we give to our customers. We have a wealth of data, network data, billing data, call service center data, net propensity score data. And we use that to work out when the right time to contact the customer is, in terms of what bundle package we want to offer. In other words, instead of offering our customers a bland offering, we personalize it specifically for the customer. And it's not just the package we offer, it's about our services, our networks, and the things we offer our enterprise customers. But I want to walk you through our vision. So this is a little bit more big, high-level architectural thinking. So this is about being on a continuum. So at the moment, we're sitting here, where we have our silos. We have our independent systems. We have duplication of data. Now, as we're moving towards the cloud, it's starting to get rid of those silos. And we see the cloud as a catalyst to achieve that. Now, the one thing that's not on this diagram is time. And actually, it would be really good, but I can't show it in 3 dimensions. But the point being is that the time to get to that peak there is actually accelerated when we go to cloud. In fact, it makes it a lot faster by using cloud to achieve the ability to do cross-market alignment. And for us, that's really important. With 21 countries and all that wealth of data, how can we align those countries? So our vision, because everyone's got data lakes, we decided to call it a data ocean. But just joking aside, let me give you context. We want to create a single place for analytics and BI. And each country will have its own lake. And within each lake, each application will have its own pond. And the important thing is we want the countries to have vertical usage of their data. But we also want, across the whole of our countries, horizontal usage by our group. Now, our data ocean is our vision to achieve that. It will remove the silos, remove the duplication, all those common words you hear us all saying. The other thing is it will drive quality because everyone will be drinking from the same lake. So our always-on marketing systems, our BI systems, our analytics systems will all take from the same location. We will not duplicate data. We will not have to reconcile. Everything will be consistent. But it's not just the data we see duplication in our world. So remember, 21 countries, 21 different systems. And the one thing that we've recognized is that we're duplicating our technologies and we're duplicating our processing. And if you look at a BI stack and an analytics stack, they're pretty much starting to look very similar below the red line. We still use the same storage. We still use the same transformation. We still use the same governance. The only time it actually changes is when we actually get into the analytics side and the BI side, when we're doing feature engineering on the analytics side, and actually we're doing semantic models and enterprise data warehouses. So what we want to do is converge them to make it simpler and more cost-effective. So this is closer to home. This is my world. I have a big on-premise platform. It uses Hadoop. Most of us, maybe in the audience, have them. It supports all those 11 countries, and it's 4 years old. And we've outgrown this platform. It's big, 600 servers, 8 clusters, 17 petabytes of data, 1,300 feeds, 226 models, and growing. And what we find is that we are not able to support our analytics. And I'll cover that later on about how critical our analytics are. So the other thing is ugly. I mean, it's like anyone, we've used every single part of the Hadoop stack. Yeah, we have everything. We have HBase, Impala, we haven't used Kudu, but we've used everything in our platform. And we've built on top of that as well. So we've also added, just to make our journey even easier to cloud, more complexity. So we have our own proprietary frameworks, and some of you guys may have that as well. The other thing is we find the platform restrictive. So in other words, our ability to scale is 6 months, not seconds. And we have no way of bringing things like TPUs in, or CPUs, or GPUs, or anything that our data scientists require. So we also are coming up to a very difficult thing, which is obviously a hardware refresh and a software refresh. And we used that point, and we decided we needed to do something different. So we then looked to cloud, and we did the evaluate the big three. And we chose Google. So I can sort of explain around all these detailed points, right? But I think it's important to call out. The one reason why we chose Google was its willingness to partner with us. Yeah? It's a leader in data analytics. It's constantly innovating. And it supports, funny enough, our vision for sustainability. And that's really important to us. So here's all the bad things. Data and storage and compute all in one box. We had to pay for loads of servers. It's really expensive. Half those servers weren't working, or weren't being used. So basically, data scientists would come in the morning, run their jobs, finish in the evening. The cluster's not doing anything. So environmentally, that's not very good. And in terms of actually using those assets, we can't scale up or scale down. As I've already said, our concept of scaling is 6 months. The other thing is also we had to deal with the complexity of all the analytics models. So by the time we had installed XGBoost or a library, we would have made such a bad job of it because a lot of it was manual. Yeah, we would have already had another inversion in front of us. So basically, we were delivering yesterday's technology tomorrow to our data scientists, and that was a cause of frustration. And what we wanted is to bring the latest technology to our customers, the data scientists. Now, the other thing we had is we have a considerable amount of investment in our in-house frameworks. And what we wanted to do is to reuse all that code, but also make sure it's cloud native. And Google we saw as a perfect partner to do that. No matter how many yarn queues you have on a Hadoop cluster and how many resource controls, we still struggle when we have Italy and Spain and Portugal all running their analytics at the same time. And what we found is by moving to cloud and by moving to Google, we will be able to create the right level of resource isolation. In fact, it becomes a non-issue. Data duplication also. So the other thing, we started with this naive concept of development and production on our Hadoop clusters. And what we ended up doing is putting the same data on both clusters. So we duplicated our data because the data scientists went, well, actually, I can't do my model training because I don't have enough data sets, so I want it all. So therefore, we have loads of big data replication jobs sharing that data all between our production. And then what happens is to deploy a model onto the production clusters that we had. It took ages, so therefore, they just turned their development environment into the production, which was terrible for operational support. So the one thing that our existing platform does, and Vodafone takes mega serious, like mega serious, is around the security. Security is critical to us because we are dealing with you as a customer's data, and that is really important. All our data is anonymized. And what we wanted to make sure is that when we chose a cloud provider, we wanted to make sure that we could have those same capabilities and more. And I think one of the ones which you sort of really hard to measure, but a lot of our data scientists were actually leaving because of the technology we had. They left because basically they got fed up with the platform, they couldn't achieve what they were doing, they started doing their work on their MacBooks, so we had grey IT, it wouldn't scale, and then they said, I've had enough of this and I'm going to someone else who's on the cloud. And the one thing is we want data scientists to be data scientists, and we want to enable them. Okay, so where are we on that journey? We made the decision. We like a lot of red at Vodafone. When it changed, everyone looked as if they had a suntan, sorry. So our mission, and we chose to do this, is, and we like a challenge at Vodafone, is to move 11 countries by the end of this financial year. So that gives me till March. And this is tight. And I think one of the things is, at the beginning of 2019, we made the decision to go to Google Cloud. Obviously, you then give it to your lawyers and legal that then spent a certain period of time, 3 months, to actually make it available to my team. So we actually got the keys to Google actually in April of this year. And we already have a cloud presence. You know, we're using other cloud providers for some of our capabilities. So the other challenge we had is there was no foundation for using Google. So apart from moving my analytics platform, what we also had to implement was all that critical parts of security, network, billing, AD integration. Now, the good thing is, thanks to Google, we were able to do that. Because usually when you bring a cloud provider to the enterprise, it's like a square peg in a round hole. And the thing is, Google allowed us to shave off those edges and do it very, very quickly. So now, where are we? So we have 4 countries with their C3 data on GCP. We also have a group service on GCP as well, where they're sharing data across those markets, and I'll cover that a bit later. Apologies for the release names. When you do pick releases, do not pick oceans, because there's only 5, so that means we only do 5 oceans. We then decided to go to prehistoric oceans. I think the very important part is that Google has allowed us to get this far very quickly. And what we've done is we've taken our whole core product, which I'll cover in a second, and migrated that in 7 months. So we've got 4 years of legacy, and we've got the core technology moved in 7 months. So our approach was not to do lift and shift. We were not going to get a rusty van, bring it to our data center, lift what we had, implement large Hadoop clusters on the cloud, because that just wouldn't work. And we wanted to approach our migration in a very different way. First, we wanted a set of core principles. So because we were rolling out in 11 markets, we wanted to make sure that it was repeatable. Now, everything our product, which we call Neuron, is templated. And the reason why is because it has to be consistent. We cannot have operations guys manually creating environments for 11 countries. It just ain't going to work. Everything has to be automated, and you guys get that. You use your Terraforms and everything. Everything we do is fully automated. Now, the other thing is it needs to be self-service in 2 ways. It needs to be easy for the ops teams that are deploying and doing the migrations, but also it needs to be easy for the customer. And also it needs to be portable. And this is an interesting thing. We are obviously leveraging containers, who's not? And what we want to do is that we have certain markets that can't go to cloud. So actually, some of the components we develop, we also want to reuse in other countries. So Egypt or Turkey, who can't implement a cloud instance. So portability is actually in the back of our mind when we design things, so that all the goodness we run on cloud can actually run on an on-prem solution. Once again, and I'll keep reinforcing this, safety and security is key to Vodafone. We want to make sure that we have defense in depth. We have a zero trust architecture. We want to make sure that all our security controls are implemented by automation. But the other challenge is, it's very easy to give someone a lockdown bit of the cloud, but then you inhibit the flexibility your users have. So we wanted to make sure it was frictionless. And it's a real hard tension, is how much control you give the country and the users, and how much you actually give them freedom. Because there's always a risk. It's not like your data center when you've got loads of firewalls and loads of infrastructures and network switches. So we wanted to make sure, and one of our mantras was to make sure that the environment for our customers was frictionless and allowed them to operate, but within a very safe bubble. Now, the 3 lines. So we had 2 work streams initially. So we wanted to develop a product. So we weren't just lifting the code, we are actually manufacturing a product which could be repeatedly deployed. What we're also doing is doing the actual country migration. So we released the product, and then we were getting feedback from the country during their migration process. What was also helpful to us is that we saw gaps or we wanted features within the Google product range. And what was great was that Google, when we wanted to say, we want this feature in Composer, or we want the fact that we want to use BigQuery in this region, or the fact that we want a change here, Google actually contributed to our release cycle. And that's pretty amazing if you think about it. A large company as big as that listening to us in Vodafone and actually writing bits of code and delivering to my timelines. And that's pretty good. But we also, because we want to be a tech company, we also want to be perceived by contributing back. So not yet, but in our next big release, we're going to actually be contributing back to the open source community. And this is a bit of a step change for our culture. So we want to contribute back to things like Apache Beam, because we're using that very, very heavily. So, apologies for the name. We couldn't think of anything catchy, so I come up with it. It was called Neuron. So let me walk through this. So this is what we built. So we took all the googly goodness, all the Istios, the VPSCs, the Kubernetes, all the data procs, data flow, GCS storage, Composer, and then we built on top of that. And we took those 4 years of legacy, we sprinkled the cloud nativeness on it, and then what we did, we filled all the gaps within that we had within our technology on-prem, and we did that in 7 months. So let's go through the bits, okay? So this bottom bit, the foundation, we put this in, but this is the enabler for any project that goes on Google at Vodafone. The networking, the AD integration, the CSOC integration, and the billing. Google actually directly engaged with our security teams and actually had their own work stream integrating ETD, Forseti, and all the tools that we use to ensure that our platform is secure. What we also have is a shared service stack. Now, instead of every market creating their own model development lifecycle platform, we actually put those core components, and that's responsible for the build and govern phases of your analytics. So we also have a catalog, which I'll cover in a sec. We also have build automation. And we also have all the relevant components where all the repos and pre-built images are kept. The other component of Neuron is the actual run, execute, and transform. And we leverage the GCS storage, we leverage Apache Beam, and also we develop pre-canned data proc images. So, you know, you've got a market that wants to use Python 2, you want a market that wants to use Python 3. You want a market that wants to use a different, country, I always say market. You've got a country that wants to use different libraries. We actually pre-can those images that they can then use. Now, here's the clever bits, and the bit I like. So we have this thing called the Data Hub project. Now, for anyone who's worked in a large organization, it's very hard to get alignment. It's really hard to get an agreement on anything. And it may sound really simple, but this sort of makes my day, which probably shows how sad I am, is that we have this concept called a Data Hub project. And what it is, it's a taxonomy. It specifies how we structure our GCS storage. It specifies how we represent things in BigQuery, how we name our projects. Now, you just try and imagine, get 24 countries, 11 countries that we're on, and getting everyone to align on that taxonomy. But we have, which means everyone has a common model to operate on Google Cloud, unlike our other cloud providers. This time, we've done it right. The other thing is that all of this builds itself. So even the shared services build themselves. Oh, there was one bit I missed, hang on. So the other bit, if I can get it to go backwards, yay, is around the facts, around our movement. So every piece of data that goes up onto GCP is anonymized. Every bit. It's encrypted as it goes as well. So let me give you an idea of how the Google platform solved our problems. So we had issues with how we run our models, our legacy feed migration, our data governance, how could we do streaming, and also our stack simplification. So when we were trying to migrate off our Hadoop stack, we had all these issues. And just to give you an idea, that 5.3 is how much one of our models in Italy generated in value in 8 months. And that model is linked to our enterprise data warehouse. That model then runs on existing model, used to run on our cluster. Yeah? That model had to run, because if it didn't run, our marketing teams in a certain country wouldn't be able to actually make the offers to our customers. So if you do the maths, and my math's not that good, but if you take that number, round it up to about 10 million, and then times that by 226 models, then we're responsible for a fair amount of revenue on our existing analytics platform, and we're moving that onto cloud. So we have to ensure that our models run efficiently and reliably. So one of the challenges we had was how we could deal with that, where our existing platform used to creak. In fact, we used to cross our fingers when this model used to run. Now, we don't worry about that. We just scale. We deal with it. Dataproc is able to scale automatically. So these models have real SLAs. So the other challenge we had is that we had an existing data transformation technology that basically took our data and transformed it into features. And what the trouble was is that all the countries were using this technology, and we didn't want to change it, and they were using it. And we thought, how the hell are we going to reconcile that? So if we introduced a whole new transformation technology on cloud, it was going to take us longest to do the migration. So what we did is we took Dataflow and Apache Beam, and we built that underneath our transformation technology. And what it did is that to the users, i.e. the data engineers in the local market, it looked exactly the same. But actually underneath, our transformation runs serverless using Apache Beam. That was great for us because it ran more efficiently. We didn't have to run very big Hadoop clusters. It was self-managed. The other thing is, our data governance was probably the Hadoop console and an Excel spreadsheet. And that isn't very good for 17 petabytes worth of data. So the one thing we wanted to do was introduce data governance. And obviously, Google has its catalog and also its partner ecosystem. And we use that to solve our problem. The other thing we have is most of our analytics are semi-batch, micro-batch. And now we want to move to streaming. And we made the right decision by going for Dataflow, because obviously we can use Apache Beam and go from batch to stream very, very easily without having to do any major changes. So this is one of my faves. So this is the Aldi of data. I'm not sure I'm allowed to plug. We wanted to make sure there was a one-stop shop for our data. It needed to be a single place. Because what our existing platform didn't do was solve that data lifecycle. Right? We had operational procedures and runbooks, and that actually was an operational nightmare. So the one thing we got with Google was the actual partner ecosystem. And we chose Calibra as our choice for catalog. And one of the reasons why is because it has great integration into data movement. It integrates well into BigQuery, integrates into Data Fusion, it integrates into data flow, yada, yada, yada. Also, though, it integrates to our upstream systems, into those oracles, into those Teradatas. So we can get all that metadata. And that's really important to us. Also, the whole process around GDPR needs to be managed. And what we wanted to do was replace all the manual processes. So actually, that's all completely gone, and we use workflows now. So all our data management is actually driven by workflows from the Calibra. Also, how we retain data, we flag data in the catalog based on its retention period. So we can automatically manage our data. And this is the lineage, all the way from a source system to a feed, to a subfeed, to a set of wired tables, to a set of Spark jobs running on Dataproc, and then to a return feed. So we can track the whole lineage of our models. And what's great about this is that we can also do that for our BI solutions. So Neuron didn't just deliver it for the analytics space, it delivered it for the whole of Vodafone. So I like this screen. Everyone else hates it in my team. Google allows us to build on top of their platform with their APIs. And the APIs are really important, and I'll tell you why. So, most boring screen in the world. Well, the reason why it's my favorite, so we call this Neuron Genesis device. Sorry, we do come up with some interesting names. The reason why this exists is we don't have a budget to offer all the countries a platinum service. The countries themselves don't want to be throttled by central admin. They don't want our group organization. Can I have an IAM role set up? Can I do this, please? They don't want to deal with remedy tickets. They don't want to deal with raising JIRAs. They want none of that. They want independence. The trouble is that we don't want the risk of someone playing around with IAM roles and making a mistake, because that's not good. So what we did is create this thing called Neuron Genesis device, which is our self-service for our countries. And basically, that gives us the full auditability of what they're doing, thanks to the APIs. Yeah? And what they could do is then create roles just by push button. So we can automate that whole process of managing IAM through the APIs, through automation. Now, underneath that, yeah, is GKE. Underneath that is BigQuery. Underneath that is all the good service APIs that we run. What we also do, I didn't put it up, but we called it the shameometer or report, is we also do a reporting, because now that our countries have moved to cloud, they're more sensitive about the costs to run their models. And what we do, we leverage BigQuery and we leverage tagging to be able to actually provide visibility of how much each country is spending. And that's really important when you have a data scientist that writes really bad code. And I'm not saying all data scientists write bad code, but you sometimes get those situations, right? So this helps us because, and it also helps each country, because they feel as if they have the autonomy. So what's next? Well, we've got our big shiny platform, yeah, but what we want to do is start leveraging those capabilities. And just to remind you, we're still migrating. So, but what we found is that we've seen a number of interesting use cases. And I don't know if they're here today, but so there's a team within our organization which is part of the group service, which is called Network Planning. And they are, I think, our 5th person on our Neuron platform on GCP. And they are responsible for our network, our masts. Now, we've done a number of activities with Google before this on moving on to GCP. But our goal is to be able to automatically detect and manage our networks. We want to be able to optimize our network investment, so where we put our masts, yeah, so that you all get better coverage. So we're using the geospatial capabilities of Google. Yeah, we're using all our master network data. And what we've done, though, and this is an example of our taxonomy and our data ocean design. This has been developed by Group and allows us to deploy it in every country's data lake on GCP. It's a repeatable pattern for reusability and allows us to make sure that we have a standard way of managing our network footprint. But the benefit of this is that we can actually start predicting that there will be a degraded network. Yeah? We can actually then start bringing automation in to actually correct that before it even impacts you, so your service is even better. So the other one we're doing, which is also a favorite, so this was developed centrally and is going to be deployed locally. So what we want to do is we determine how we place our stores. And as you know, we've just purchased Liberty. And our goal is to work out what's the best way of doing it. So we take a large amount of environmental data. We take a lot of external data and social data. We then mix that up with a bit of geospatial. And what we have here is a bit like a monopoly simulator. So if we put a store here, exactly what we think the revenue is going to be like. Yeah? We also look at whether we should have a store there and whether we should actually be using a more digital channel because of the demographic in that area. So this is what we call smart retail. And we also are then combining it is actually what devices should we actually sell in that store? Because actually you don't want to walk into a store and there's nothing that you want in there. Yeah? How frustrating is that to you? So we use this, and this simulates and allows us to inform our decisions. Behind that is obviously BigQuery's geospatial capabilities that we use to drive this. And once again, it's a repeatable pattern that we put across our countries. So, this is something that is quite important to us. And actually, the demo that follows will actually show some of the real demos, so real geeky stuff, after the show. So I recommend you look at it. But one of our biggest challenges is around our data movement and its cost. And if you look at how big we are and our mergers and acquisitions, we have a number of different source systems in each country, in its own data centers. We also have loads of different technologies. So if we're trying to get data onto the cloud, let alone within our big on-prem big data platform, we've got multiple hops that we have to go through. Sometimes 5. And also this becomes, and 5 is a magic number, this is 5 times more expensive than having a centralized system. Now the trouble is that we want to get the balance between a country having the local autonomy to do what it likes in terms of extracting the data, but we also want control from a group perspective as we bring it into the data ocean. Also, the other challenge is when there is a data issue, especially when you have such a critical model, we don't have a thing called a DOC, a data operations center. We have localized ops guys that know how to fix it, but we want to implement a DOC, a data operations center, that allows us to manage the whole inflow of data from upstream to downstream into our data ocean. So, and this is one of the benefits of working with Google. So it's very rare that you get direct access to, so we're working with a guy called Nitin Motgi, right? And we're also working with a number of tech partners, one called Cogniflare. And what we're developing is we're prototyping the concept, right, of a data bridge, yeah? And that connects directly to our source systems all the way to GCP. Wow. Okay, it's a little bit more than that, right? What it allows us to do is we can put our data curation at the edge or right next to the source. And we're using CDAP, which is obviously the open source part, and it's now become Data Fusion. And we're running that on Anthos on-prem. But what we're also doing is we're running Data Fusion on GCP, and we're tethering it, which means we control both of them centrally via GCP. Now, what we're trying to achieve here is a single backplane to move our data. And what's cool about this is that the local markets with their Teradatas, oracles and so ever, obviously know how to write the select star from that source, or a network probe. So we give them that ability and freedom to do that. But then what we do is we insert into that components that allow us to validate data quality. And our goal is to push data quality upstream. You do not want to be doing data quality on your data lake or data ocean. It's too late. You then write a whole set of data quality services that you have to keep running on your data ocean. Push the problem upstream. And we see us writing the modules that do the data quality, and we see the local market doing the extraction, the country doing the extraction. And then what we see is all the transformations are at different stages as we move along that data bridge. All this awesomeness, yeah, makes our life a lot easier into one single solution that allows us to manage it centrally and allows us to actually ensure that the data that goes on our ocean is clean, curated, common, and to a standard. So, the journey so far, I just want to be clear, I was at this show last year, and we were still trying to work out which cloud provider we were going to use. And I definitely didn't expect to find myself on this stage. And I have to say that I wouldn't have been on this stage, although I think someone's going to give me a T-shirt afterwards. That's the bribe, isn't it? But the point being is, I didn't expect myself to be on this stage. And the reason why I am is because actually Google have been a great partner. And I wouldn't say that the relationship is very positive, right? And there are times where I've said, look, I'm not happy with this, you need to fix it. And it's having a partnership where people will say, okay, we get that, we want to do something, we need to fix this. Google lean in, right? And that's the one thing we love about our partnership with them. When we were doing our releases, so there's a lot of Vodafone people here, but when we're on the deployment and on the releases over the weekends, during the Scrum calls, Google are on those Scrum calls. Their techies are there. When we had issues with one component, they flew in a team for us. So I want to say thank you to Google for being an amazing partner. I also want to say to other partners we've had, like Reply and Cogniflare and so on, thank you very much. Most importantly, the hecklers who haven't heckled, my team, for doing an amazing job in 7 months. And I also want to say to the countries who have accepted us trying to roll this out, and more importantly, for you, for listening to me. Thank you.